Hello and welcome to the TechGig podcast, folks. I'm your host, Sukriti, and I'm here with another episode that talks about the scope of hardware engineering. Employment of computer hardware engineers is projected to grow 5% from 2021 to 2030, about as fast as the average of all occupations. About 5,300 openings of computer hardware engineers are projected each year on an average over the decade. Demand for computer hardware engineers is expected to grow as they are needed to design parts for manufactured products that use processors and other components, such as household appliances, medical devices, and automobiles. As new technologies expand, however, an unexpected uptick in focus on software innovation compared with the hardware may temper demand for these engineers. To deepen the understanding of hardware engineering and the opportunities, I'm in conversation with Preetam Tadeparthy, Chief Technologist from Texas Instruments. Welcome to the show, Preetam.
Thank you, Sukriti. I think it's a pleasure to be on this TechGig podcast. And I really look forward to sharing some of the innovations and how we do it at Texas Instruments in power and how do we make differentiation come through into day-to-day lives. I look forward to the discussion.
I'm delighted to have you on the show, Preetam, with me. So let's get started with the questions. So, with trillions of data created every minute, data storage is becoming increasingly energy heavy. Can you elaborate on how power solutions help these centers, data centers, optimize energy efficiency?
That's actually a great question, right? See, I think our requirements have evolved over generations. What used to be just a requirement for a phone call now has become evolved into a quality of phone call, quality of a video call, and so on. And that actually directly drives into the server architectures, the data center architecture, the storage centers architectures, and of course the network switching solutions. And that is actually available through very high-end processing that comes at a cost of high power. There is significant technology that goes into how you save power, but I think the most important portion of energy efficiency is how you manage power. Like, let's just take a quick example, right? Like today's data centers draw kilowatts of power in order for us to do the processing that we're looking for, the quality output that we deliver. And imagine, like, trying to deliver a kilowatt of power in a small volume of like an inch cube. And that is actually nothing, like from a power density standpoint. And today, there are, in my opinion, three dimensions of technology innovation that enables this kind of a differentiation in power. One, the silicon evolution. That would include, like, these GaN FETs and silicon carbide based FET solutions that TI is spending a lot of innovation and energy on. And these GaN solutions are coupled with extremely innovative designs that actually get the best out of these GaN solutions using GaN drivers and control solutions that give us the best possible efficiency. And the third dimension, right, like once the process, another is the IC design itself, and the third is the packaging, and that actually is the most important piece as well, because imagine you actually will have some kind of a power dissipation in your system in spite of doing all these great technologies. Now, what is very important is how do you take that power that is hosted in your device and bring it out without causing extra temperature differentiation, right? So that is where we drive package technology, which will enable us to almost keep flat temperatures. Like we try and maintain 85 degrees C with even 2x the power that we deliver from these devices. To me, all these three dimensions in parallel is what enables us to create differentiated and energy optimized data centers that we have today. I,
Wonderful.
I hope I.
Yes. Also, Preetam, as we speak, a lot of horizons have expanded amid the innovating technologies that we look at today. And I think energy industry is one of those where people have, more scopes that they can look at. What kind of career opportunities are available for people working in the, in the power technologies?
So let me give you a spectrum picture of what power really is, right? So there is, like we just talked about, extremely high power that actually deliver kilowatts of power, and there is also processor and the data center power has two pieces to it. One is the wall power, which is the AC to DC, and then the DC to DC, which is actually powering the processor itself. That's one section where we're talking about kilowatts of power being delivered per board. And for a rack, it's probably megawatts of power that you deliver. And all this being done in a very efficient, thermally efficient way to save dollars that come out of cooling is the one big pillar in power technologies. I'll give you a picture of an extremely opposite solution, right, which is the nano power technology. That actually is also an equally important and a very, very powerful applications where in like sensors or medical equipment, like or in-house home electronics, all these also drive extremely low power, like nano power technology that is equally powerful, and that is including AC to DC nanowatts, DC to DC nanowatts, and so on. And the third pillar, in my opinion, that is extremely important is the precision power. Right? At the end of the day, what we really want is we want predictability in our equipment or in the usage of our devices. Right? You go to a medical equipment, for example, you want to be able to take that pulse oximeter reading or your BP machine to be able to consistently give you the same result or the result that you really are expecting over the life of that device or the equipment, right? And that actually comes through what we call precision power, which is driven by precision references, precision uh, power technologies through ACDC, DCDC, and again LDOs and then references, right? So these are the three major pillars that directly drive leadership in power. And to me, career in any of these three domains will directly expose you to the front end of power technology. What are we really trying to achieve and how power differentiates in any of these three vectors.
Okay. So if an engineer wants to work in the analog power team, what should they be studying, or what skills and educational qualifications do they need?
No, that actually is a very interesting question, right? In my opinion, Sukriti, I don't think I will be able to put my finger on this particular topic and say, hey, you know what? You read this and you will be a perfect fit for power domain. Like today, I think the world has evolved going beyond a particular course or a degree that we attain. And I think everything is spread over multiple, and it's all multidisciplinary and I guess, like cross-disciplinary in a strict sense. Give you an example, right? When we talk about power, design in power or research in power, we're talking about process, which is semiconductor. When we talk about IC design, which is primarily any analog electronics or digital electronics or power electronics or any kind of IC design that goes with that kind of a solution. And then I also talked about package technology, which is all modeling and all those aspects. And then I'm talking about the tools that come and associate us to be successful in all these solutions. Like none of this is possible if you didn't have tools, and which is actually semiconductors or power centric tools that are very efficient these days from a modeling standpoint for power solutions, modeling standpoint from a thermal solutions, and so on. So to me, a multidisciplinary approach with a focus towards trying to achieve excellence in power solutions, which would include IC design understanding, strong IC design understanding, with well complemented process technology and package technology understanding, is really where you would go in. Now, that is from an analog design standpoint. I think one key strength or key step that a student or an engineer would get would be a good understanding of some amount of signal processing, because at the end of the day, power, whatever it delivers, is still a sample system for most of the applications. A good understanding of control and signal processing will give a huge edge to our understanding of what we just prepared as a part of analog design and semiconductor process technology. To me, that is the key.
I see. I think you've very well comprehended that for our audience. Tell me what excites you to, come to work every day to build these technologies. If you could share a glimpse of a day at work for a hardware engineer.
So let me take this question a little differently, right? I'll give you what we go through in our day-to-day life, right? I think To me, a right ecosystem is the beginning of real impact technology that you can create. Right? Over over the years, what you build as your culture in the work environment, technology innovation, technology differentiation that you created, and the people that who created with you is what really motivates you to come to life, come to work every day. And I'll tell you one thing that as a student, we've all gone through the experience of a great teacher or an academician who really enabled and kindled that spirit or charm of the challenge in that technology is what really sticks with us. For some it is electronics, some it is computer science, some it is signal processing or whatever. It actually starts with the teacher, right? Now that teacher is really the one who has actually shown you what is it in there that kicked your intellect and said, "Wow, man, this is really cool. I want to be part of this development, right, or this technology." And that's what sticks with you when you try and drive and go to that particular field and say, "You know what, I like that topic." That's how we all as engineers pick a topic mostly, right? And now imagine that in a work environment like in Texas Instruments, where you have such good teachers and such strong technically established mentors in a day-to-day life, where you every day come to office and you will actually see them in work every day. Then imagine what kind of environment that you've created, right? And that work environment where you have strong experts, young engineers who are willing to take risk and then push technology and help these senior engineers who have very strong experience and are great mentors. When you put these things together, right, what you get is a perfect mix of technology satisfaction, professional satisfaction. And at the end of the day, you want to go back in the evening to your home and feel satisfied of what you've achieved in the day. So you get efficiency, you get professional satisfaction, you get technology innovation. You get all three. To me, that is what motivates me to go to the office, and this is how I see every day when I go to office. It's what I see in office. I hope that it gives you a picture of what we do in power here.
Absolutely, Preetam. And I'm sure, there's a little bit of motivation and inspiration there as well for our audience to understand what does the day often, engineer like you or leader like you looks like. So thank you so much for that. I have thoroughly enjoyed this conversation and hope you had a good time too.
Oh, I certainly did, and I think I like your questions. Because I think we have a minute or two, and I do want to leave the audience with one thought process, right? I think see, when we talk about technology, right, like we associate technology with our end user experience, right? Like, what am I really enjoying today? It could be 5G. It could be like, my phone battery runs for 2 days watching 4K resolution movie. Or it could be like, I have an automobile that actually I step on my e-vehicle gas and then it just keeps going for 600 miles. It does not matter, right? I think we all associate our kick from the day based on the technology that we get excited with as technologists, right? And I think the future is out there where I think there are so many challenges that are not addressed today. But I think at the end of the day, just imagine, right? I'll give you an example of an e-vehicle. I think we've all experienced it. You fill a gas, you fill your gas tank in your car, 40 liters at 15 miles or 15 kilometers per liter, and you have a 500-kilometer journey and you don't have to worry about it. Worst case, what happens? Like, you see your car in reserve, you stop at a gas station, you fill it up, and then you're on your way. Imagine, can you have a similar experience where you have an e-vehicle, where you've charged your e-vehicle at home, you sit in a car and you're driving 400 miles down the line, you see, well, my battery is at 10%. I think I should charge it. You drive up to a so-called battery gas engine, and you stop it up there for 15 minutes because that's how much time you spend to fill your petrol today in a gas station. You stop it up there, 15 minutes, you're ready to go for the next 500 miles or 500 kilometers. And that is where we are tending towards. Right? Today, it is just, you can't even imagine that it's possible. And I'm just giving you one dimension of technology that is so far away and we want to get there. And I think that is what we should aim for as technology. That young engineers who are itching to come up with technology, that's our goal. That's our aim. We walk in with that approach. I'm sure the experience in a technology company like Texas Instruments will be just very unique and pleasurable journey. With that, I'll hold.
Thanks, Preetam. I think that was a very lovely thought you've helped us conclude the conversation with. Thank you so much, audience. I hope you enjoyed this conversation and you have had your set of learnings from what Preetam has just shared basis his experience in the industry. For all the latest tech updates, please stay tuned to TechGig. I will be back with another episode very soon. Preetam, thank you so much for your time once again. Please, everyone, stay safe and take care.